Hey, so for Notes 11, now that we've spent some time in Notes 9 and Notes 10 talking about confidence intervals, we're going to revisit some of the assumptions that we saw from back in Notes 3. So all of the different confidence intervals that we've seen so far are going to be directly analogous to the confidence intervals that we've done, or the hypothesis tests that we've done. So we've got a one sample hypothesis test, paired sample, and two independent samples. And you can see the test statistics that we had back in Notes 3 on that reference sheet that we kept referring back to during Exam 1 material. And for confidence intervals, we've got a confidence interval formula for each of those three scenarios as well. And so anytime that we make a confidence interval, we've got those same conditions or assumptions that we need to check to make sure that our intervals are actually meaningful and doing the things that we want them to do, basically. So we're going to revisit some of the assumptions because now that you've got some more tools at your disposal, there's some better ways that we can look at some of these. So the first assumption for all three of the different scenarios that we learned is that our data comes from a random sample. But we haven't spent a lot of time actually talking about what a random sample is. So random is one of those words in statistics that has a little bit of a different meaning than maybe how it's sort of colloquially used. So when we say random in statistics, we mean that there's some sort of chance mechanism that's being used. And it's doing it in a way that everyone or everything has a chance of being included in our sample. So common examples of this are like the box houses activity. You had SAS generate some random numbers for you, and those random numbers were random. Every house had an equal chance of being selected and taking part in the sample of 5 houses. Other common examples are things like drawing names from a hat. Maybe you've got some way of like rolling a die or flipping a coin or something like that. And the reason that we really like random samples is because our overall goal is actually to get a sample that's representative. And when we say a representative sample, we mean that our sample looks like the population. So for example, if the population is all people living in the US, I want to make sure that I've got young people and old people, I've got people with all different incomes, I've got all different religious preferences and things like that, but I want them to be in sort of the same proportions that you would see in the US. All right? And so the thing that random samples do is they make it so that nobody is favored more than anyone else. So we're not favoring people who are older or younger. We're not favoring people who are higher income or lower income or anything like that. And so this gives us a really good chance of getting a representative sample. And the other aspect is we don't necessarily, I can list things like age, income, and whatever else, but there's other things that I'm probably not thinking about. And as long as I'm taking my sample randomly, if I forgot to consider that, maybe people have different sort of like rural or urban areas that they're born in, um, I don't have to worry that I forgot about that because everybody still had that same chance of being selected. And so random samples, as long as they're big enough, they do a good job of giving us representative samples, which is our overall goal. And so one thing I like to think about as well, would our class be considered a random sample of ELAN students? And it might at first sort of seem like it because, you've got a good mix of different people. But when you realize that random means having that chance mechanism, we realize that no, I guess our class really isn't random because you chose to be in it. We didn't just take people from all over Elon and say, you're going to take Stats 212, Section B or Section C or whatever it might be. And if we go a little further and we say, okay, well, our class isn't a random sample, but is it a representative one? We still realize that probably not. In some ways, we might seem representative. We do have students from all 4 years. We do have students from lots of different majors and things like that, but probably not in the same proportions as Elon as a whole. And so it's likely that our class probably has more first and second year students than Elon as a whole. We probably also have a greater proportion of people in sort of science type fields. We have a lot of people from like biology and psychology and stuff like that in this class. And so this would not be a good sample to use to necessarily learn something about Elon as a whole. If we wanted to do that, we would need some way of sort of getting people at random. So maybe drawing like student ID numbers from a random number generator or something like that.